hidden fire and precision transform raw iron into powerful steel, shaping the modern world through extraordinary metallurgical technology. The success of modern heavy lifting operations depends greatly on the capability and reliability of advanced crane technology. The Liebherr LR1600-2W crawler crane and the Liebherr LTM1500-8.1 telescopic truck crane. Together, these cranes represent the perfect combination of power, flexibility, and engineering precision required for complex industrial projects. The LR1600-2W is a structural crawler crane designed specifically for heavy-duty applications. Mounted on narrow-track crawler undercarriages, it offers excellent stability and mobility even in confined or challenging job sites. With a maximum lifting capacity of 600 tons, this crane is ideal for large-scale installations such as wind turbine assembly in wind farms. One of its main advantages is the wide variety of boom configurations available. These include the heavy main boom, light and heavy main boom combinations, a derrick boom system, and fly jibs for extended reach. The crane can achieve a remarkable maximum lifting height of up to 166 meters, making it suitable for high-altitude operations. Additional features enhance the efficiency and safety of the LR1600-2W. It is equipped with a floating counterweight system, quick connection stabilizers, and automatic leveling functions. Operators can control the crane's traveling movements remotely, improving precision during delicate maneuvers. Electronic walkways and access ladders ensure safe maintenance and inspection, while advanced control systems allow smooth and accurate load handling. All these characteristics make the LR1600-2W a preferred choice for infrastructure projects requiring extreme lifting performance. Complementing the crawler crane is the LTM1500-8.1, a powerful telescopic crane mounted on an 8-axle truck chassis with a maximum capacity of 500 tons. This mobile crane is designed for rapid deployment and high versatility. Its telescopic boom extends up to 50 meters, and with additional jib attachments, the lifting height can reach 84 meters. The crane supports several boom configurations, including fixed and luffing fly jibs, allowing it to adapt to a wide range of lifting requirements. The LTM1500-8.1 also features the SuperTIF system, which increases lifting capacity and stability for demanding operations. Being truck-mounted, it offers excellent road mobility, enabling fast transport between job sites without the need for disassembly. This makes it an ideal solution for projects that require both heavy lifting power and quick setup times. Together, the LR1600-2W and the LTM1500-8.1 demonstrate how modern cranes work in harmony to accomplish complex maneuvers. The crawler crane provides enormous lifting strength and height capability, while the telescopic crane offers flexibility and mobility. Their combined use allows operators to handle oversized components with precision, efficiency, and maximum safety. These two machines clearly illustrate the remarkable progress of engineering in the field of heavy lifting equipment, providing essential tools for today's most demanding construction and industrial projects. The installation of the SL6000 crane luffing attachment is a highly structured engineering operation that requires careful coordination, precise lifting procedures, and strict attention to safety. The process begins with the preparation and assembly of the front strut, a major structural component weighing approximately 4.9 metric tons. Using an assist crane, the front strut is suspended horizontally and carefully lifted toward its fixing position at the tip of the main boom. Once correctly aligned, the strut foot pins are inserted to secure the base connection. These pins are followed by holding pins, which are locked firmly in place using split pins to prevent accidental movement. At the upper end of the front strut, the support ladder is attached, along with connecting links that will later be used for jib guideline installation. Each connection is carefully checked to ensure full structural integrity before the next stage begins. The next phase involves the installation of the rear strut assembly, which has a weight of approximately 4.8 metric tons. A link assembly is first attached to the rear strut, and then 6-meter guidelines are connected to this link structure. Unlike the front strut, the rear strut must be suspended vertically during installation. With the help of an assist crane, it is guided carefully into its designated fixing position at the top of the main boom. The footpins are inserted and securely locked to complete the primary attachment. Once secured, the rear strut is slowly lowered onto the back of the front strut, forming the fundamental structural framework for the luffing system. After the struts are positioned, attention turns to the guide sheave located on the rear strut. This sheave is raised to its operational position with the assistance of a crane to maintain safety and stability. Wire rope from the W2 winch is then paid out and reeved between the front and rear struts. The end of this wire rope is fixed to the load detector using a rope socket located at the top of the rear strut. It is important to note that the exact termination method of the wire rope may vary according to different national standards and regulations. Once the mechanical connection is complete, the electrical cable for the luffing jib load detector is connected securely, ensuring proper monitoring capability during crane operation. The rear strut is then raised again with the assist crane and carefully guided backward. At this stage, both the main boom guidelines and the rear strut guidelines are connected using pins. Two different methods are available for this operation. One in which the front strut is held by a second assist crane, and another in which the rear strut is drawn backward using the winch. The selection of method depends on site conditions, available equipment, and overall assembly requirements. Following this, the rear strut is inclined slightly forward to allow temporary removal of the lower pin from the backstop. After repositioning, the strut is inclined backward again and the backstop is attached. Hydraulic hoses for the backstop cylinder are connected, and the tank valve is firmly closed. Holding pins are inserted to fix the backstop at the correct set length. Once all these operations are completed and verified, the sling used to suspend the rear strut is detached from the assist crane and the strut is stowed securely. Attention now shifts to the installation of the jib assembly. The front strut is hoisted slightly to allow connection of the 10-meter jib guideline. The jib base, which weighs approximately 3.8 metric tons, is then prepared for installation. It is lifted to a safe height where it will not interfere with other components during positioning. The base machine of the crane is swung carefully to bring the attachment into the correct jib fixing position. A wooden block is placed at the boom tip to provide protection and stability during this phase. Once the jib base is in place, the insert jib sections are assembled and connected. The jib top section, weighing around 3.7 metric tons, is then added to complete the structural length of the jib. With the full jib assembly complete, it is lifted by the assist crane and guided carefully toward the fixing position on the main boom. The jib foot pins are inserted and locked securely with holding pins to ensure a rigid and reliable connection. After the mechanical structure of the jib is secured, various auxiliary systems are installed. Electrical cables for optional equipment such as hookover systems, aircraft warning lights, and monitor cameras are connected. These devices are hoisted into position and mounted as required. The jib backstop is attached next, and the cable for the jib overhoist limit switch is connected. Technicians carefully verify the fixing position of the backstop support to ensure that no assembly errors have occurred. The installation of the jib guidelines follows. Guidelines are run from the jib tip and connected to the required anchoring points, including the previously installed 10-meter jib guideline. These lines play a critical role in maintaining stability and alignment during crane operation. With the structural components fully assembled, the focus moves to rigging the lifting ropes. Wire ropes from the H1 and H2 winches are paid out and routed through the strut sheave, idler sheave, and finally to the jib point sheave. Sufficient rope length must be paid out to prevent the wire rope from slipping backward when the attachment is raised. This stage requires particular care, as incorrect rigging could lead to dangerous operational issues later. The luffing boom is then erected to a specified jib offset angle that allows the jib point to lift safely off the ground. Wire ropes from the H1 and H2 winches are reeved to their respective hooks according to the crane's lifting capacity chart. Sockets are attached to the rope ends and locked firmly in place. The hook overhoist limit switch is installed and tested to confirm correct functionality. Finally, the entire luffing attachment is erected gradually while maintaining the proper jib offset angle corresponding to the attachment length. This delicate operation ensures that all components rise in a controlled and balanced manner. Once the attachment is fully upright, a comprehensive inspection is carried out. All safety equipment, including limit switches, load detectors, structural pins, and hydraulic connections, are thoroughly checked to confirm that they are functioning correctly. Only after every mechanical, electrical, and hydraulic system has been tested and verified is the SL6000 crane declared ready for operation. The entire installation process demonstrates the complexity and precision required in modern, heavy lifting equipment assembly. Each step, from strut installation to final erection, plays a vital role in ensuring that the crane performs safely, efficiently, and reliably in demanding construction environments. Global maritime transport is growing at an extraordinary pace. Every year, millions of tons of goods move through international ports, and only the most modern and efficient harbors are able to keep up with this demand. Large vessels require deep channels, reliable waterways, and advanced transshipment facilities. In this demanding environment, specialized heavy machinery plays a vital role. Among the most impressive of these machines is the Liebherr R995 Pontoon Excavator, a giant floating excavator designed specifically for hydraulic engineering and port construction projects. Liebherr Pontoon excavators are used worldwide on large-scale water infrastructure projects. Whether dredging riverbeds, expanding ports, or maintaining navigable channels, these machines deliver the power, reach, and endurance required for continuous heavy-duty operation. To strengthen its capabilities in international marine construction, the Hamburg-based company Mobius Bau expanded its equipment fleet with the Liebherr P995 Litronic. With this addition, Mobius became better equipped than ever to participate in major hydraulic engineering projects around the world. The Liebherr R995 is currently the largest pontoon-mounted excavator operating in Northern Europe. With an operating weight of approximately 360 tons, it represents the pinnacle of floating excavation technology. The machine was assembled in the historic port of Hamburg, near the famous St. Michael's Church. Construction began with the installation of a massive elastic suspension unit measuring 7.70 meters in diameter. This suspension system forms the crucial connection between the pontoon platform and the excavator's upper structure, absorbing enormous forces generated during digging and slewing operations. For transport and assembly purposes, the pontoon was delivered to the Mobius Harbor facility in modular sections. Meanwhile, the hydraulic excavator itself was manufactured by Liebherr France in Colmar and transported to Hamburg by inland waterways. From the moment the components arrived, teamwork became essential. Every movement had to be carefully planned and precisely executed. Specialists from both Mobius and Liebherr worked side by side throughout the entire assembly process. A Liebherr LTM 1500 mobile crane, capable of lifting up to 500 tons, played a central role in the installation. This powerful crane unloaded the massive components and positioned them with extreme accuracy. The heart of the excavator, the 60-ton upper carriage, often described as the backbone of the machine, was installed first. This structure supports all major modules, including the power pack, hydraulic tank, fuel tank, counterweights, operator cabin, and working equipment. Within only a few days, the enormous P995 began to take shape. Observers and technicians alike were impressed by its sheer dimensions. The next major step was the installation of the working equipment. A massive monoblock boom, measuring 16 meters in length and weighing several tons, was carefully aligned and mounted onto the upper structure with millimeter precision. This operation required great experience and coordination, particularly because the assembly took place directly on the water. Working in the port of Hamburg presents unique challenges. The River Elbe is influenced by tidal movements, meaning the water level is constantly rising and falling. These changing conditions force the assembly team to repeatedly adjust the position of components. After several careful corrections, the monoblock boom was finally secured in its bearings. At this stage, the P995 became operational and capable of positioning itself for the installation of the stick. Depending on project requirements, the excavator can be equipped with different sticks measuring 6.5 meters or 9.6 meters in length. A wide range of working tools is also available, enabling digging depths of up to impressive limits. Backhoe buckets with capacities of 11 to 14.5 cubic meters can be fitted, specially designed for hydraulic construction. These buckets include water drainage holes and reinforced wear protection to reduce abrasion when working in sand, mud, or other challenging materials. Ease of maintenance is another key feature of the Liebherr R995. The entire upper structure is safely accessible, allowing technicians to perform inspections and servicing without difficulty. Corrosion-resistant materials are used extensively, including stainless steel exhaust systems, protected lubrication lines, and sealed hydraulic components. These features ensure long service life even in harsh maritime environments. For additional safety, Mobius chose to equip the machine with a combined powder and foam fire suppression system specifically designed for pontoon excavators. Inside the machine, all areas are fully walkable, even around the large power pack. Accessibility and safety were clearly major priorities in the design. At the heart of the R995 is a powerful MTU water-cooled diesel engine producing approximately 2,140 horsepower, 1,600 kilowatts. To protect sensitive electrical systems from seawater, they are housed high inside the raised cabin structure. Once fully assembled and tested, the 360-ton machine was ready to prove itself in real working conditions. Its first major assignment awaited in Bremerhaven, northern Germany, at the container terminal of Wilhelmshaven. This port handles around 3.4 million containers per year, a number that continues to rise. To meet growing demand, a massive expansion project was launched, including the construction of more than 1 kilometer of new quay walls and 4 additional berths. Behind the quay, a container storage area of around 900 hectares was also developed. Such construction requires a solid foundation. The seabed had to be cleared of a mixture of silt and sand before being refilled with approximately 100 million cubic meters of load-bearing sand. Mobius was tasked with dredging this material to depths of up to 15 meters below sea level. In total, 265,000 cubic meters had to be removed in just 6 weeks. Working around the clock in 3 shifts, the Liebherr R995 operated tirelessly. With an average loading cycle of only 45 seconds, the excavator could fill barges of 950 cubic meters in less than 1 hour, achieving an impressive productivity of around 1,000 cubic meters per hour. Such performance demonstrates why machines of this class are essential for modern port development. Environmental protection is a major concern for Liebherr. Pontoon excavators often operate in sensitive ecosystems, so the R995 uses biodegradable hydraulic oil and fully sealed bearings to prevent contamination. Special marine-grade paint protects the structure from saltwater corrosion, while compressed air systems prevent water infiltration into critical components. Reinforced cylinder guards and nickel-chrome piston rods further increase durability underwater. Even equipment changes at sea are routine for this machine. Integrated platforms on the boom make tool replacement safer and faster. Powerful lighting systems allow safe night operations, and the spacious, ergonomically designed cabin ensures operator comfort during long shifts. Positioned 7 meters above deck level, the cabin offers excellent visibility over the entire working area. Advanced electronic systems support the operator, including underwater visualization technology assisted by GPS. Using dual monitors, the driver can dredge with an accuracy of within 5 centimeters, even when the bucket is far below the water surface. In case of electronic failure, an independent analog backup system allows the machine to continue working without interruption. The immense mechanical forces generated during excavation are absorbed by the elastic suspension system, preventing damage to both the excavator and the pontoon. The swing ring features internal gearing, protecting it from external impacts, a unique Liebherr design. Maintenance points are easily accessible from the outside, simplifying regular inspections. Thanks to the Liebherr R995, the new container terminal facilities were completed far more quickly than originally planned. Once finished, the expanded quay installations, nearly 5 kilometers long, became the largest river port terminal in the world, capable of handling 5.5 million standard containers annually. The successful deployment of the Liebherr R995 pontoon excavator clearly demonstrates the importance of advanced engineering in modern maritime infrastructure. Combining extraordinary power, precision, reliability, and environmental responsibility, this remarkable machine sets new standards for hydraulic construction. For Mobius and Liebherr alike, it represents a major technological achievement and a decisive contribution to the future of global port development. This onboard view shows a Manitowoc 6400 dragline actively working at Keystone Anthracite, digging hard rock to uncover valuable coal seams. The machine is equipped with a massive 180-foot boom and a 12 cubic yard bucket designed for heavy-duty excavation. From the operator's cab, the video reveals how the dragline is carefully controlled using a simple but highly effective mechanical system. A large lever on the left side of the seat controls the swing motion of the entire upper structure, allowing the bucket to be positioned accurately over the digging area. On the right side are two main levers that operate the drag and hoist functions, giving the operator precise command of the bucket's movement and depth. Two heavy foot pedals mounted on the floor act as independent brakes for both the drag and hoist drums, enabling smooth stopping and steady control even under extreme loads. During operation, the bucket is lowered to the ground, pulled toward the machine to gather material, and then lifted and swung away to dump the broken rock aside. Each cycle demonstrates the enormous strength of the Manitowoc 6400, a classic walking dragline built specifically for large-scale surface mining tasks. The rhythmic sound of gears, cables, and engines highlights the purely mechanical nature of the equipment, which relies on operator skill rather than modern computerized automation. With every pass, tons of overburden are efficiently removed, gradually exposing the coal seams beneath the surface. This onboard perspective clearly illustrates how such machines remain essential tools in the mining industry, combining durability, power, and practical design to perform demanding excavation work day after day. Ultimately, the Manitowoc 6400 proves to be a reliable and productive giant of earth-moving, steadily uncovering resources that power industry and support modern life around the world. At Freedom Mine, a giant dragline equipped with the CQMS Earth Eater bucket works continuously to uncover coal seams. The machine is designed strictly for moving dirt, not loading trucks. In a single scoop, the bucket lifts about 330,000 pounds of overburden and dumps it into previously mined pits. The pit measures roughly 150 feet wide and 85 feet deep. This lighter, improved bucket increases productivity, reach, and dumping efficiency. Its shape and internal chain placement allow more material to be carried safely and economically. 5 buckets remain in regular site rotation daily overall operations. The assembly of the Liebherr 996B mining excavator is a highly organized and carefully controlled process. It begins with undercarriage placement, where the massive crawler base is positioned on a prepared foundation to form the structural core of the machine. Next, the upper carriage assembly takes place. Using heavy lifting cranes, the upper module containing the engine, hydraulic systems, and operator cab is raised and precisely secured onto the undercarriage through the swing ring. After the main structure is completed, attention turns to attachment installation. The boom, stick, and bucket are assembled and connected to the main frame. This stage requires accurate alignment of pivot pins and secure fastening to ensure safe operation. Technicians then complete all hydraulic and electrical connections, installing high-pressure hoses, SAE split flanges, and control wiring. Access components, such as powered ladders and safety catwalks, are mounted and bolted into place. The machine is then filled with hydraulic oil, fuel, and lubricants before undergoing fluid circulation and system checks. Finally, engineers perform detailed testing, calibrate the Latronic Plus control system, and confirm that every function operates correctly before the excavator is declared ready for work. A heavy-duty excavator is carefully loaded onto a transport vehicle using only its own hydraulic power and the operator's skill. Instead of relying on ramps or external lifting equipment, the machine performs the entire operation intelligently using its bucket and crane. Initially, the CAT 330D excavator is positioned behind a low-floor trailer. The operator slowly aligns the tracks with the rear of the vehicle, ensuring everything is balanced and stable. Due to the excavator's considerable weight, the loading process must be performed with high precision. Any sudden movement could cause imbalance or damage. To begin climbing, the operator lowers the bucket to the ground above the trailer floor and uses it as a pivot point. By pressing down on the boom and arm, the front of the excavator is gradually raised. This action allows the tracks to lift off the ground and move towards the edge of the trailer floor. Step by step, the machine ascended, almost like a giant mechanical animal. When the front tracks reached the trailer floor, the operator repeated the same technique. The bucket was firmly placed back on the ground, and the hydraulic system was used to pull the rest of the excavator up. Throughout the operation, gentle and controlled movements were essential to maintain balance. After a few careful adjustments, the entire excavator was successfully loaded onto the transport vehicle. The operator placed the machine in the middle of the trailer and prepared to secure and transport it. This process demonstrated both the impressive capabilities of the KT330D and the experience required to operate such powerful equipment safely and efficiently. The Liebherr HS 8130 HD duty cycle crawler crane demonstrates outstanding performance in a challenging dredging application. Working at the Olivone water intake facility, the machine operates in difficult terrain and unstable ground conditions where falling rocks and access create obstacles. Equipped with a heavy-duty mechanical two-shell grab specially optimized for depths of up to 200 meters, the crane removes submerged sediment and debris from the reservoir floor. This material must be cleared to restore full operation of the hydroelectric intake structure. Despite harsh weather and demanding job site requirements, the HS 8130 HD provides reliable power, precise control, and excellent mobility, proving the right equipment for complex underwater excavation tasks. The Maeda Mini Crane MC815C is a highly versatile and compact lifting machine engineered for demanding lifting tasks in confined spaces. Designed with advanced technology and robust performance features, the MC815C delivers exceptional control, safety, and efficiency on construction sites, industrial facilities, and maintenance environments where larger cranes cannot access. Its blend of precision handling, intelligent operation modes, and environmental compliance makes it a reliable partner for professional crane operators. One of the MC815C's most notable features is its joystick-type radio remote control system. This intuitive remote allows the operator to control the crane from a safe distance while maintaining full visibility of the load and surroundings. The joystick-style interface provides smooth, responsive control over boom movements, slew rotation, and lifting functions. Operators benefit from reduced fatigue and improved safety because they do not need to be positioned in or near the cab during operation. Complementing the remote control system is the crane's self-leveling function. This intelligent mechanism automatically adjusts the crane's upper structure to keep it level as the outriggers extend and settle on uneven ground. Whether the crane is positioned on firm ground, slopes, or irregular surfaces, self-leveling ensures stable operation and precise load handling without constant manual adjustments. This function enhances safety and reduces setup time, making the MC815C highly efficient in dynamic job site conditions. The MC815C also offers multiple operating modes designed to match the task at hand. Powerlifting mode is tailored for heavy lifts, optimizing hydraulic performance, and boom power to safely raise substantial loads. In contrast, multi-lifting mode provides versatile load handling for complex lifting scenarios that may involve more dynamic movement or coordination across multiple axes. These modes give operators the flexibility to adapt the crane's performance to different loads, tasks, and site requirements. Environmental responsibility is another key aspect of the MC815C. It is powered by an engine that complies with the EU Stage 3B emissions standard, incorporating a DPF-type diesel particulate filter system to reduce harmful exhaust emissions. This compliance ensures that the crane meets stringent environmental regulations, minimizing its ecological footprint while maintaining efficient combustion and power output. The Stage 3B engine also contributes to quieter operation, which is beneficial in urban or noise-sensitive job sites. Safety features are extensive on the MC815C. The height limit setting and slew limit setting are programmable safeguards that prevent the crane from exceeding user-defined operational limits. Operators can set maximum boom heights and rotation boundaries to avoid collisions with overhead structures or nearby obstacles. These limits protect personnel, equipment, and the surrounding environment while allowing operators to focus on precise load placement without over-travel risk. In terms of lifting capacity, the MC815C is capable of pick-and-carry operations up to 1.0 ton, allowing loads to be lifted and transported short distances without additional rigging or repositioning. This adds significant workflow efficiency, particularly in confined indoor or outdoor spaces. For enhanced reach and versatility, the crane can be equipped with an optional 1.5T hydraulic-type fly jib, which extends lifting reach and enables higher load placements while maintaining hydraulic precision and control. At the end of operations, the MC815C includes an auto crane stow function. This intelligent feature automatically repositions the boom, outriggers, and rotating superstructure into its transport configuration with minimal operator input. The result is a safer, faster transition from working mode to travel mode, reducing downtime and simplifying logistics at the close of the workday. Overall, the Maeda Mini Crane MC815C combines intelligent design, versatile performance, and professional-grade safety features, making it an ideal choice for contractors and operators seeking reliable lifting solutions in tight and challenging environments.